Hello and welcome to Nikolai's genetics lessons, and today we are going to talk about correlation and correlation coefficient. And this is not going to be my first video on the topic. I highly recommend you to watch my previous videos, and I will post links to those videos. And my explanation is based on the textbook Animal Breeding and Selection. And in this textbook, the whole chapter is about how to calculate correlation and correlation coefficient with 5 pages of theory and 15 pages of formulas and calculations. And I don't want to multiply misery in this world, so I decided to make not one video but break this topic to many small videos, so you would learn just one conceptual ideas from each video, and then we will tie all these ideas together and you would be able to do different calculations and understand the conceptual idea behind a correlation and how to find correlation coefficient. You can watch these videos in a row, or you can take break, grab a snack, drink a tea, go skiing or skating, or catch a wave if you live in Hawaii. Let me repeat what we have learned from the previous video. As Russian proverb says, repetition is the mother of learning. So here on the first graph, we see positive correlation when we have a data set of two parameters, let's say x and y, and when one parameter grows, another one also grows. But what about this parameter that below this line? Does this represent negative correlation? No, it's still positive correlation. When one parameter go down, another parameter also go down. So it is positive correlation, and line in the middle just represent mean of the population. And graph here on the right represent negative correlation when one parameter, for example x, go up, another go down. So one more time, in the first graph all parameters go in one direction with some exclusions, for example, like what we see here, or what we see here, or for example here. But on the overall, all parameters, when they change together in the same direction. But here, these parameters that go in couple would change, and would change in the different directions. When one would grow, another would decrease. When one would grow, another one would decrease. And again, also we see here some exclusions, like this example, this example, this and this. But on the overall, we see here strong negative correlation. One more time, when we talk about correlation, we are talking about a relationship between two data sets. For example, in this column and in this column, and we compare couples in these data sets. Here is ice cream sales versus temperature, temperature in Celsius, and ice cream sales in dollars. And what we see here, for example, at temperature 14 degrees Celsius, sales are $215. If temperature goes up, sales also go up. If temperature go down, sales also go down. What we see here, we see positive correlation. And when there is no correlation at all, we would see a graph like this. In such a case, we can see sometimes that one parameter go up, another down, then both go up or both go down. Some may go up just a little bit, and another one can go down to much greater extent. So there is no actually correlation between x and y. All I have said you already should know from my previous video, and today we are going to talk about the scatter plots, which I also showed in my previous video. But today we're also going to talk about correlation coefficient, which we see here, and in just a minute I will explain you all these numbers. For example, all these three scatter plots here would correspond to this graph here. We see here positive correlation, but it can be of the different kinds. First, for example, it can be perfect when we for example, plot one number on the x-axis, we can predict number on the y-axis because we see here perfect line. We can predict also with high degree of certainty. If we know one parameter, we can predict second parameter because we see here perfect positive correlation. But sometimes it can be not that perfect, still positive. But as you see, for example, from this graph, we have exclusions here. We also have some variation. And now you see that these numbers here represent how these numbers are scattered, and maximum what we can get would be 1 when we can predict with high degree of certainty. Just knowing one parameter, we can predict second parameter. And for example, here is going to be no correlation, which correspond to this graph. If we have negative correlation, the slope goes in different direction. You see direction here when one parameter grows, another grows. When one parameter go down, another also go down. Here we have different slope when one parameter grow. You see one parameter grow, another at the same time go down. So go in different directions. That's why we have here negative slope. And also it can be between 0 and -1. And -1 actually means also predictability, which we can predict with high degree of certainty second parameter if we know one parameter. And if this correlation coefficient would be smaller than 1, -0.9 for example, we would see that numbers can fluctuate around some perfect line here, and here fluctuations even can be greater. It is very important, one more time, we can get correlation between 1 and -1, and the closer correlation coefficient is going to be to 1 or to -1, then the stronger would be correlation between data sets of x and y parameters. And the smaller the number or closer to 0, then there is less stronger correlation between data sets. And one more time, -0.9 doesn't mean that correlation is weaker than 0.9. Actually, they're equal. But if, for example, we compare 0.9 and -0.5, we can say that here is correlation stronger. But if we compare 0.5 and -0.9, we can say that here correlation is stronger. Correlation cannot be greater than 1 and smaller than -1, and the closer number to 0, then the weaker correlation is going to be between two data sets. And in my next video, I will explain how to calculate correlation coefficient. And this is all for today. Thank you for attention. Please subscribe for my new videos that I post almost every day. And see you in the next video. Goodbye.